Chapter 13, Part 3, Archimedes Principle. Archimedes Principle states that the buoyant force on an immersed object is equal to the weight of the fluid it displaces. Archimedes' principle describes the relationship between buoyancy and displaced liquid. It was discovered in ancient time by the Greek philosopher Archimedes. This is the 3rd century before Christ. Archimedes' principle is true for liquid as well as gases, which are both fluid. Let us start by demonstration that a liter of water will occupy 1,000 cubic centimeter, which has a mass of 1 kilogram and weight is 10 Newton. Any object with a volume of 1 liter, accordingly, will experience a buoyant force of 10 Newton when fully submerged in water. Immersed means either completely or partially submerged. If we immerse a sealed 1 liter container halfway into water, obviously it will displace half a liter of water and be buoyed up by the weight of half a liter of water. If we immerse it all the way, which is mean completely submerged, it will be buoyed up by the weight of a full liter of water, which means 10 newtons. Unless the completely submerged containers become compressed, which means that has a constant volume, the buoyant force will equal the weight of 1 liter of water at any depth. The container will displace the same volume of water and hence the same weight of water at any depth. The weight of this displaced water, not the weight of the submerged object obviously, is the buoyant force. A block weighs less in water than in air, as shown in the figure below. The buoyant force on the submerged block is equal to the weight of the water displaced. Let us try to explain this experiment. A 300-gram block weighs about 3 Newton in air. If the block displaced 2 Newton of water when it is completely submerged, the buoyancy force on the submerged block will also equal to 2 Newton. The block will seem to weigh less under water than above the water. The apparent weight of submerged object is its weight in air minus the buoyancy force, which will be equal to 1 Newton. Please note, for any submerged block, the upward force due to the water pressure on the bottom of the block minus the downward force due to the water pressure on the top equal the weight of a liquid displaced. As long as the block is completely submerged, depths make no difference. There is more pressure at the greater depths, but the difference in pressure on the bottom and top of the block is the same at any depth. So the difference in the upward force and the downward force acting on the completely submerged block is the same at any depth, since it has a constant volume, no compression. Archimedes' principle could be applied for the gas too. So when we apply Archimedes' principle in air, the more air an object displaces, the greater the buoyant force on it, obviously. If an object displaces its weight, it flies at constant altitude. If an object displaces less air, it runs down. Examine your understanding. If 1 liter container filled with mercury had a mass of 13.6 kilogram and weight 136 Newton, when it is submerged in a water, what is the buoyant force on it? The answer is the buoyant force will be equal to the weight of 1 liter of water, which is about 10 Newton, because the volume of displaced water is 1 liter, in spite of the fact that the weight is 136 Newton. We're only dealing with the volume. So another example, a block is held suspended beneath the water in the 3 positions, A, B, and C. In which position is the buoyant force on it is greatest, assuming that it has a constant volume? The answer is obvious. There is no change in the buoyancy force in the 3 position because the volume is constant and the displaced water in the 3 cases will be the same. Another example, a stone is thrown into a deep lake. As it sinks deeper and deeper into the water, does the buoyant force on it increase, decrease, or remain unchanged? Answer, the volume of displaced water is the same at any depth. Water is practically incompressible, so its density is the same at any depth, difference from air obviously, and equal volume of water weight the same at any depth. The buoyant force on the stone remain unchanged as it sinks deeper and deeper. This is the answer. Now, if we have 2 solid blocks of identical size, which means they have the same volume, both are submerged in a water. One block is lead and the other block is aluminum. Upon which is the buoyant force greater? As we explained before, because both have the same volume, so the buoyant force on both will be the same. So the answer will be C, same on both. Check your understanding. What does Archimedes Principle state?